Greetings, mathematicians. Welcome to this little narrated PowerPoint on the cast diagram. Now, if you've been doing trigonometry for any length of time, you will have come across this acronym, CAST. Hopefully by the end of this session, you will know what it's all about. Let's go back to the beginning. Basic trigonometry. Trigonometry is all about the ratios of different sides of right-angled triangles. Now, along with all other right-angled triangles, the longest side, the side opposite the right angle, is called the hypotenuse. The other two sides are named according to their relationship to the angle in question. So this side here is called the adjacent side because it is adjacent to the angle. And this side here is called the opposite side because it is opposite to that angle. So our three basic trig ratios are as follows. Sine is the ratio of the opposite and the hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now we can take this exact same concept and transpose it onto a Cartesian plane like this. Here we have a Cartesian plane. Here is point P with its coordinates, and a line is drawn from the origin of the Cartesian plane to point P. This line now creates an angle between the positive x-axis and the line. Creates an angle that we're calling theta. This line also creates a right-angled triangle because if I draw a line straight down from point P to the x-axis like that, huzzah! I have a right-angled triangle. Now the sides of this particular right-angled triangle are slightly differently named. This is no longer called the hypotenuse, it is called R. And it is called R because if I take this point P and move it around the origin like this, then the line R actually acts as a radius of a circle. Furthermore, this side here is no longer called the adjacent side, it is called X, because the length of this line here corresponds to the X coordinate there. So for instance, in this case, if that X coordinate was 5, then the length of this line would be 5. This side of the triangle is now called Y, because the length of this side corresponds to the Y coordinate there. So there is our triangle on a Cartesian plane. This is what our trig ratios look like on a Cartesian plane. Sine is no longer opposite over hypotenuse, it is y over r, although you will notice this is the opposite side and that is the hypotenuse. So actually all that's changing is the names of the sides, not the actual trig ratios themselves. Cos is now x over r, that's the adjacent side over the hypotenuse, and tan is y over x, that's the opposite side over the adjacent side. So all the concepts are the same. The only thing that we've changed is the names of the sides. Okay, a couple more details on the Cartesian plane that are necessary. If I have my line like that, which creates an angle theta here, if I were to change this angle, for instance, if I was to make it bigger, this line would move around the Cartesian plane in an anti-clockwise direction like that. So we need to figure out what angles would be where on the Cartesian plane. Well, if this line was lying flat on the x-axis, that angle between the x-axis and the flat line would be 0 degrees. If I move this line anti-clockwise to here, in line with the y-axis, the angle it would create over there would be 90 degrees. If I was to move this line anti-clockwise all the way around to the other side of the x-axis, this angle that it creates there would be 180 degrees. Likewise, if I was to move the line all the way around to here, that reflex angle there would be 270 degrees. Finally, if I was to move this line from the x-axis anti-clockwise all the way around back to the same place, that would create an angle of 360 degrees. For ease of reference, we call this quarter of the Cartesian plane, this quadrant, we call it quadrant 1. This is quadrant 2, that's quadrant 3, and that's quadrant 4. It would do us well to note the following, that to the left of the y-axis over here, all of our x-coordinates are negative. All the x-coordinates to the left of the y-axis are negative numbers. And below the x-axis, all the y-coordinates are negative. So all the x-coordinates are negative here, all the y-coordinates are negative here, which means in this quadrant, quadrant 3, both the x and the y coordinates will be negative. Let's use this information now to figure out which trig ratios are positive and or negative in which quadrants. So which of these ratios are positive and which of them are negative in each of the quadrants. In quadrant 1, if we think about sine is the ratio of the y-coordinate over the length r. The length r is always going to be a positive number because it is the length of the line, the length of the radius. In quadrant 1, y is positive, the r is positive, so sine will be positive. In quadrant 1, if we look at cos, the x-coordinate is positive, the r is positive, so that whole ratio will be positive. And finally, in quadrant 1, the y-coordinate of tan will be positive and the x-coordinate of tan will be positive. So that means the whole tan ratio will always be positive in quadrant 1. If we now move to quadrant 2 and look at sine, the y-coordinate is still going to be positive in quadrant 2 because all the y-coordinates up the top here are positive. The r is always positive, so a positive divided by a positive will make our sine in quadrant 2 positive. If we look at cos now, the x-coordinates in the second quadrant are negative. So that's going to be a negative x-coordinate. The r is always positive, so a negative divided by a positive will give us a negative. Now if we look at tan, the y-coordinate in quadrant 2 will be positive, but the x-coordinate in quadrant 2 will be negative. Come back, cursor. So a positive divided by a negative will give us a negative. So you'll notice that only sine is positive in this quadrant. If we do the same thing in quadrant 3, sine in quadrant 3, the y-coordinate will be negative, the r will be positive, so sine is negative. The cos ratio in quadrant 3, the x-coordinate will also be negative, and the r is positive. So a negative divided by a positive will give us a negative. The tan, however, because in quadrant 3 the y is negative and the x is negative, a negative divided by a negative will give us a positive. Finally, in quadrant 4, if we look at sine, the y-coordinate is negative, the r is positive, so sine is negative. Cos, the x-coordinate in quadrant 4 is positive, the r is positive, so a positive divided by a positive is a positive. Are you positive? I'm positive. And finally, in quadrant 4, tan, the y-coordinate will be negative, the x-coordinate will be positive, which means tan in quadrant 4 is negative. Now if we look at all of these trig ratios and identify which of them are positive in which quadrants. Well, if we look in quadrant 1, all of them are positive. The A stands for all. If we look in quadrant 2, just the sine is positive, so the S stands for sine. In quadrant 3, which of the ratios is positive? Just the tan. So the T stands for tan. And in quadrant 4, just the cos is positive. So these letters tell us which trig ratio is positive in which quadrant. So in quadrant 1, all of them are positive. In quadrant 2, just sine is positive. In quadrant 3, tan is positive. In quadrant 4, cos is positive. That is what the cast diagram is. CAST just stands for which trig ratios are positive in which quadrants. Now, I don't know what's going on here, because as we all know, you're not allowed to walk your fish during a lockdown, although perhaps this mask here helps prevent the spread of coronavirus. Now, some examples. State whether the following are positive or negative. So I'm just going to, there we go, sine of 195. Is that going to be positive or negative? Note, we're not asking what the value of sine of 195 is. We just want to know, is it positive or negative? So it'll help us to get our cast diagram. The angle 195, where is that going to be? Well, if 0 is here on the positive x-axis, and 90 is there, and 180 is there, that means 195 is going to be somewhere in this quadrant. And is sine positive or negative in this quadrant? Well, according to our cast diagram, only tan is positive in the third quadrant, which means sine must be negative. All right, you can try these yourself. Pause the video, write down an answer. And now that you've paused the video and written down an answer, let's see if you were right. Cos of 315 degrees. Well, 315 degrees is going to be in this quadrant because that's 90, that's 180, that's 270. So 315 will be here. Is cos positive or negative here? It is positive. Now tan of 120, that's 90. This is 180, so it means 120 must be somewhere in this quadrant. Is tan positive or negative in the second quadrant? Well, the S tells us that only sine is positive here, which means tan must be negative. Next example, state the quadrant in which each of the following is true. So question A, we're trying to find out which quadrant sine is greater than 0 and cos is less than 0. So greater than 0 is another way of saying positive, and less than 0 is another way of saying negative. So we want to find out where is sine positive and cos negative. Well, in which quadrants is sine positive? It's positive in the first quadrant and the second quadrant. In which quadrants is cos negative? Well, cos is negative in the second quadrant and the third quadrant. So which quadrant is this where sine is positive and cos is negative? Must be the second quadrant. Right, now you try this one yourself. Give it a go. Pause the video, write down an answer. And now that you've done that, let's see if you were right. We're looking for the quadrant where tan is negative and sine is also negative. So where is tan negative? Tan is negative in this quadrant and tan is negative in this quadrant. Then where is sine negative? Sine is negative in quadrant 3 and quadrant 4. So which quadrant are both tan and sine negative? It's quadrant 4. There we go. I hope that's given you some insight into the cast diagram and how it works. Have a good day now. Okay, bye-bye.